Here's a bit of a problem that will let us look at to the rate of change in proportional relationships a little bit more. Let's say that you're going to some sort of fair or carnival and you see three different lemonade stands. And from those different lemonade stands, we've kind of taken pieces of information to make a little bit of a math puzzle for us today. Here's Sally's lemonade stand, and they're advertising two lemonades for $11. Here's Bill's lemonade. We've taken the prices of if you bought two lemonades, it would be $10.50. Four lemonades would be $21, so on and so forth. We're also going to assume that they're selling the same size drinks. Okay, so there's no advantage going from one to other. They've got the same recipe, same amount of sugar, same amount of lemons and water, same cup. Okay, so the only thing you're concerned about is which one's cheapest. And then we have a third stand down here, and we're only going to give you an equation where y equals $5.75 times x. And it represents where x is the number of drinks and y is the total cost. Now, when we do that, if we could keep track of how much it costs for one lemonade, we'd be able to figure out which one's the cheapest. I also want to go through and build equations from all three of these. And since Joe's equation was given to us of y equals 575x, we'll take a look at this one right here and just plug that in. Now let's go to Sally. Sally has two lemonades for $11. So if we divided 11 by 2, we'd quickly find out that we could get one lemonade for $5.50. So one down, two more to go. Let's take a look at Bill's table. You notice, to make this problem a little bit more effective, we've not given you the price of one drink. Now, if I was able to take the cost and divide it by 2, I would get $5.25 or 5.25. And if I take 21 and divide it by 4, I would get 5.25. And if I take 31.50 and divide it by 6, I would get 5.25. And that tells me it's a proportional relationship. And the rate of change, I'm just going to put ROC, is the same all the way through. Okay, so my rate of change is constant. As a result, it's proportional. If I take my rate of change and I times it by the number of drinks, I can figure out what my price is. If I times it by 1, I get $5.25. So my cost for Bill's lemonade is $5.25. I could also take this rate of change and figure out a lot of other information. If I times it by 2, I'd get $10.50. I could also times it by 3 and figure out how much it is and put that into the table. If I times it by 4, I do get $21. If I times it by 5, I could figure out what would go in between here if we had 5 drinks. So that rate of change is very useful. Now, when you first see this, a lot of times people just don't understand that the answer's already been given to you. I mean, it's literally been handed to you with this equation. Since x is the number of drinks, if I put a 1 in there and times it by 575, it'll tell me the total cost because y is the total cost. So I know that my answer is 575. So one lemonade is 575. Do you know that right here with this equation, literally this number that's multiplying the x is your rate of change in a proportional equation? So if I wanted to go build an equation for Bill's lemonade, I could say y equals 525x. And I could build another equation for Sally's saying y equals 550x. And if I'd given you nothing but equations, you could have looked at this rate of change slot right here and said that 525 was the cheapest lemonade, saved yourself a lot of hassle. But to make things more interesting, we gave you a little bit of a puzzle here, a table here, and the equation here. And in each one of these equations, the y is the total cost, and x is simply the number of drinks. So therefore, we would call these numbers that are multiplying the x, the number of drinks, we would call that our rate of change. Now, that being said, let's go through and take a look at another type of problem. Let's say that there's this annoying little dog named Fido that's barking at you. And after 1 hour, he's barked at you 30 times. And you've got 60 minutes, so he's not barking nonstop. But after 5 hours, he's barked at you 150 times. And I would say we're all getting annoyed if after 10 hours he's barked 300 times. So the question is this a proportional relationship? Well, we know that the rate of change needs to be constant to make it a proportional relationship. How do we find our rate of change, which we can abbreviate with the letter K? Well, we take our y and we divide it by x for these simple relationships. So 30 divided by 1 is 30. 150 divided by 5 is 30. And 300 divided by 10 is 30. So basically, my rate of change is 30. So is this a proportional relationship? Yes. I also know it's a positive one because this is a positive number. So if I was to graph it, it would be going up to the right. So the longer it goes for this length of time, because this is my x value, time, the longer that it goes and the more time that goes by, the higher the number of barks will increase. So that y is increasing also. And as far as building an equation to represent it, if I have the rate of change, we use this generic formula of y equals k times x. So if I was to replace the k with the rate of change from this table, I'd be done. So I could just say, okay, y equals 30 times x. And here's the whole heart of this lesson right here. What does the equation mean? Well, x is the number of times Fido barks. Where am I getting this from? Well, go back up to the table. Okay, let's look at the table. This first row is your x column. So when I look at this x in the equation, it's corresponding to the x in the table. So what's it represent? And you see the dilemma that we have here. X does not represent the number of times barked at by Fido. You look at this table and you go, what's it represent? The number of hours. So let's come down here and let's fix that. And that's what I want you to do, is I want you to start using the table to tell you what the x is. Because if you have a table, then you can look at the equation and it'll tell you x is the number of hours that have passed. Y is the total number of times Fido's barked at you. And 30 is the rate of change. Actually, let's call it the constant rate of change, because I just want to emphasize to you that it's not changing, okay? Is the constant rate of change happening in the relationship or occurring in the relationship.